On last week's episode, Anna McDonald gave us an introduction to Kafka streams. We're going to deep dive today on Kafka streams and time and all of the issues related to that. There's so much to think about there when it comes to stream processing and real-time computations of events, and Anna's going to help us with that on today's episode of the Real-Time Analytics Podcast. Let's listen in. Hello and welcome to another episode of the Real-Time Analytics Podcast. I am once again your host, Tim Berglund, and I am once again joined in the virtual studio by my friend, Anna McDonald. Anna, welcome to the show.
Thank you very much. Again, I'm excited.
Again.
Today what are we talking about today? I have props.
Oh, good. They're props. Well, let's get there. This is part 2 of a 2-part series on Kafka streams with Anna McDonald. She is I'm going to say world-class expert on the topic. Maybe not every little piece of it, but you're kind of one of the best in the world.
Thank you.
Yeah, and you're great at explaining it. So if you want to know who Anna is and you want to know the basics of Kafka streams, back to that episode. I'll just say you are a customer service technical architect at Confluent.
Almost got it this time. Success.
Customer success technical architect at Confluent. I got it right on the first try on part 1, so I encourage you to listen to part 1, linked in the show notes. Anna, welcome back.
Thank you.
Kafka streams. So we kind of got some basics down in part 1, and there's some thorny issues. I remember I asked you when we did that interview a question that I have occasionally been asked myself, like, why would I use this library? It's got all this complexity and stuff. Why not just do my own stream processing? And we kind of walked down that path of how quickly, frankly, daunting levels of complexity come up in stream processing. One of those things is time. So nice. Okay. I've got a Kafka topic. It's this unbounded sequence of messages, and I'm processing them. What's the problem? Where's time come into the equation?
Right. And I think, the thing that people need to understand, and anybody who's ever run a batch job or managed a batch job or touched a batch job or heard about a batch job understands this. If I run a batch job on a system and I count how many records it's able to process from one run to the next, time's rarely the same. Why? Because something else could be going on that server. There could be contention, system resources, right? And that, when I say time, I mean look at your watch time or look at your phone time, right? That's wall clock time.
Yes.
Now, when we talk about analytics, it's really important to understand and have guarantees about semantics, which means that I don't care about an overloaded server when I'm trying to look at my results. My result set should not depend on the capacity of whatever I'm running it on, right? And so that's called, when we look at that and we say, okay, we're going to consider time based on incoming data rather than the wall clock. That's what we refer to as stream time. And what that means is that the only time, like Kafka streams has, in it, it keeps the thing, right? It calls it, stream time, right? What's the the latest message that I've seen? And when I say latest, I mean the kind of timestamp that I look at of a message, right? An incoming message. That's the only thing that advances the internal time that Kafka streams keeps. And when you do that, what that means is, right? If my Kafka streams application dies and 2 hours elapse, and it comes back up, not only does it pick up right where it left off in terms of consuming, but it picks up right where it left off in terms of time. So that's the difference.
Time is then.
Well, it bases off the message. So the time is when it last stopped consuming. That's the way I like to explain it and think about it, right? So, to Kafka streams, it goes, okay, the time is when I stopped, not 2 hours later.
Now, this implies, you said this, but I want to underscore it, that the messages have a timestamp. So an event, in some sense, knows when it occurred out in the world, right?
Well, you have to think about this, right? Like by default in Kafka, and this is again why Kafka Streams is tied so closely to Kafka, hence Kafka Streams. It's not called, Anna Streams or Kool-Aid Man streams. Sorry, I'm like stuck on that now since I got to throw that in last episode. It's because when you look at Kafka, you have to have a timestamp in your record, right? So even if you don't specify a timestamp, right, it can use log append time, right? The time the message got to Kafka on the broker side, right? It could use the produce time. And the cool thing about Kafka Streams is you can also set your own timestamp extractor. That means that if there's something in your message, in the payload, in the value that you want to be the time, you can do that as well. So yes, there has to be a time, but you don't really have a way not to have a time. So it's not something you need to think about. Right. It's not something you need to think about unless you want to.
And right, generally, like domain wise, you'll know. It's not going to be a surprise to you that you have a timestamp field, because probably you'll spend some time thinking about the time an event occurs, and there'll be some way that time is measured. And when we say wall clock, there's always a wall clock, right? There is the time that computer thinks it is. Mm-hmm. And that could be the IoT device producing the message, making an MQTT connection and putting it in the topic that way. That could be, suppose you don't have that, but there's a producer now that sends a message to a broker, and the message is acknowledged, and then it's the time that the broker thinks it is.
Correct.
That becomes the timestamp. So it's wall clock on the broker. And so wall clock, when we say wall clock, that just means the time that this computer thinks it is. And this is a little bit of a broader question, and it would be a good topic for a future episode. But in a distributed system, which this explicitly is, right? Who knows what the devices are that are producing? Kafka Streams is a cluster, or the Kafka topic is a cluster. What even is now, right? There isn't a now. There's just every computer has a clock, and hopefully they're close. Right?
Oh my gosh. And yes, that is, like clock drift in a distributed system. That's a whole nother podcast episode. And it sounds like a super fun one, and I would listen to it.
Okay, I'm going to do it. I'm going to write that down. We're done here. But I mean, every computer has a clock, and they're probably all running NTP. And in the real world, they're probably all plus or minus 10 milliseconds of each other. But we need to be more precise because, like you said, we need repeatable semantics. You need to kind of know what's going to happen. So that's the basics of time. How does this carry this forward into Kafka Streams? What happens from here?
Yeah, and so again, right, like when we look at especially like analytical use cases, any sort of analytical use cases, data doesn't really become interesting until you analyze it. Hence the analytics portion of it, right? It's like the root word. And when we talk about analyzing data, usually we like to look at it in terms of time, right? Those are commonly referred to as windows. Yes. And so that's really why Kafka Streams is powerful for, some analytics use cases, is because out of the box, right, you've got these window types where it's already taken care of. It's very, very well thought out by, among other people, Dr. Matthias J. Sachs. I'm keeping my running streak of never not saying Matthias's name on a podcast.
I love it, and I would just like both of us to stop and say hi to Matthias right now. Matthias, if you're not listening, that's a problem.
You should be. Yeah. Well, actually, Matthias and I one time got in trouble on the quiet car on the Amtrak going to New York City for talking too loudly about sliding windows. It was great. It was right after the pandemic, and I was like, we're back. But because there's just so much nuance there. There's start time, there's end time, there's what do we do about this? Well, what about late arriving records, grace period, all these wonderful, complex things that Kafka Streams has taken an opinionated stance on and coded in guardrails.
And I want to say one thing for the uninitiated. I remember struggling with this when I first came to the space. Streaming analytics, the stream is unbounded, okay? Messages are happening. They're never going to stop. They stop if you go out of business or if you turn that system off, because 30 years from now, there's a better way to do it, right? They don't ever stop. And so if you're doing analytics on that, just keep it simple. You're grouping and aggregating. That's fine, right? That's got enough pieces in it. You're grouping by something and you're computing an average of some measurement within that group. Do you want an average over all time? Like it started in time out of mind, and it's never. Is that what you want, or do you want it of the last 5 minutes or the last day or something? I mean, even in old school data warehouse type stuff, you had the idea of grain because you wanted to know per hour, per day, per week. So that window is always a thing. You don't want all infinity. You want some slice of time, like you were saying. So,
well, absolutely. I always put it this way: like, if you wanted to analyze how many people with brown hair, right, bought, let's say, like Rihanna's new lipstick line at Sephora,
okay.
right? Like, I go to Sephora. Do I go every day? No. So even if you could, and can you get the accurate data of an entire population of brown haired people in the entire world who shop at Sephora?
Probably
No.
going to cost more money
Right.
than you have. Yeah.
Right. And so you really do need to rely on a sample, right? Not the population. And I think that's kind of gets down to the heart of what you're saying is analytics involves sampling, and sampling naturally leads to windows.
Okay. Yes. It's
like you're peeping in, like, hey, on any given Thursday, how many people with brown hair are shopping at this Sephora?
What was it on Thursday? What was it in the last 5 minutes, the last whatever it is? You have some time window. And
that's correct.
You can define those. I sense there is more complexity waiting to be dropped on the audience here.
Well, there is, and I think window types are confusing for good reason, because they are complex. And so I am doing a talk at the Real Time Analytics Summit.
By the time this episode drops, that talk will probably be available, and if so, will be linked in the show notes. You should watch it. Yes.
And I'm going to dig, much deeper into this when we talk, but I really want to give people a core understanding of the window types, because depending on what you're trying to do, picking the right window type is insanely important. And so, it makes sense when I think about windows, and I was actually talking again to Matthias today, and I said, well, I'm giving these a nickname because these are very confusing to people. They don't understand the difference, and it's much more accurate to call them this. And he's like, that is true. I mean, that is pretty good. Yes, I like it. So, that's kind of what I'm trying to do, is to make these more accessible for people so they choose the correct window from day one, and get the results they're looking for. So, if you want to dig into the 4 types of windows in Kafka Streams at a very high level, I am happy to do that today.
Most people are processing this or receiving this as audio only, and most window explanations are fairly visible. I think we can do it, Anna. Let's do it.
All right. So in Kafka Streams, out of the box, we have, a high level 4 types of windows. You've got hopping, you've got tumbling, you've got session, and you've got sliding, right? It almost sounds like the Olympics for gymnastics, right?
It really hopping, it feels very active. Yeah.
It is. It's very active, right? And these are actually found in most stream processing platforms, or a variety of these, right? So it's not, this isn't something that's specific to Kafka Streams, right? How they're implemented is different, and you need to understand that in each system that you're using, right? Or may be different. But overall, the concepts are the same. And so hopping windows are basically, the way I like to think of them is, when you're carrying something heavy behind you, like, has anyone ever taken out like a Christmas tree or like one of those large bags they're donating, and it's so heavy and you kind of have to like drag it behind you, right? But you're making a little bit of progress, but it's still there and hopping forward. That's kind of how you can think of those. You have your window size, and then you have how much you can advance. So I like to think of it as like your window size is like you and the huge Christmas tree. And like your advance is how many steps can you take before you got to like put it down because it's so heavy, then you pick it, go. So they overlap with each other. Yeah.
If I want an average of the last minute, then my window size is a minute.
Yep.
But I might hop that forward a second at a time.
Right. It's including a little bit more data as you go. Yeah. Right. Yeah. So you're like, hey, I want to include this much of, the ground I've already covered, but this part should be new.
So 61 seconds ago gets booted out of the average calculation, and the most recent second gets included as a
kind of. Yes.
Okay.
Right. Kind of. Yes. So it's like window size and kind of advancing, right?
Yeah.
And then tumbling windows for people who are doing like analytics where you're following your assumptions and it's actually more closer to mass stat, they will be like your heart of hearts.
Okay.
Because unlike hopping windows, tumbling windows never overlap.
Okay.
And so when we talk about independence, in samples when we talk about, observations not being included in more than one sample, right?
That's
Those,
humbling.
yes.
Okay.
And those are, kind of very near and dear to my heart. So they're unique. They never overlap.
Okay.
Right. And they're kind of, amazing to me.
So that's funny that you have a very warm response to tumbling windows. So again, let's say we're grouping and averaging over some measurement over the last minute. That means the previous 60 seconds, I have this window, this average calculation, and that is computed. And then in another 60 seconds, I will have the average of all of those messages in that window.
You got it.
Do I have to wait 60 seconds?
Absolutely not.
Oh, that's a relief.
See, now you're just like, I'm glad this is coming out after my talk because huge spoiler alert, right? So I've come up with a name for this. And what I call it, right, it's almost like your assumption predicates or your predicate template, right? So a lot of times when you're doing analysis, you're like, I really would love to get this data faster, but I don't want it unless this, and this are true. Some of those are, mathematical assumptions, such as in order for this to be considered a normal distribution, I need at least 30, right?
Samples. Okay.
Yeah, I need at least 30 observations. Okay. Otherwise, you're not doing proper statistics.
Right. Okay.
I'm giving the dead eyes, like, don't do that.
Okay.
Right?
And greater than 30. Got
Absolutely.
it.
Pearson Darling will yell at you.
Okay.
It's a test. It's amazing. And so some of them are like that, but other ones might not be as math stat. They might be something like, look, right, until I get data in, like maybe I'm looking across all of these locations, right, statewide. Let's say that we're doing something where we're sampling from point of sale systems.
Okay. And grouping by maybe store ID or something, right?
Right. Or highest charge of the day.
Oh, okay.
Right. Like, let's say that's what we're studying. So let's just say that, what I really need is I only need 3 from each state. Right. But how do I know when I can emit when I have 3 from each state? Oh, I know how you do. Right. Those types of criteria you can put into Kafka streams and it will say, okay, you can block emitting of whatever analysis you're doing until those criteria are met.
Okay. So effectively, I won't have a result until those criteria are met.
Correct. Now, you can omit it if you want, but to me personally, right, and I did a demo. I have like some sample code that I'm going to use. What I'm saying is like, if it comes in and it doesn't meet them, bat that one to the ground. Because Kafka Streams will automatically emit a new update every time a new member comes in, a new message comes in. Now, we'll talk about this in a second, but that's if you have criteria and you want it before the window closes.
Which is exactly why I asked that question. It sounds, when you talk about tumbling windows, it sounds like, oh, gee, okay, well, my latency on average is half my tumbling window size. That kind of sucks. Nobody wants that. That's not true. Your latency is,
right,
smaller, something on the order of how often messages occur.
However, this is
by the window, unless you've got these other predicates in place, which is you saying, I'm not so much worried about latency. I'm worried about correctness. I can't have a result if these predicates are not met. It's
now,
not a
Tim,
result. Yeah.
This is the funny part.
All right.
So by default, that's the way Kafka Streams always worked.
Yes.
It would always emit a new result as things came in.
Which got a little tiresome. And this was
people did not like that all the time. And hence we introduced suppress. Yes. So suppress is an operator. And what suppress will do, you can suppress for a time limit. You can suppress until the window closes. Right?
Okay.
And so if you don't want to look at it until the window closes, you can. To me, though, like, that's cool. Go ahead. However, I think it's much more fun instead to go, well, it's fine if I don't get what I want by the time the window closes, right? But why would I wait till the window closes if all of my predicates and all my assumptions are met? Give it to me now. Give it to me now. Mm-hmm. Right. And so that's kind of I think personally, just the power of Kafka Streams is to improve your ability where you don't have to wait and go, okay, well, I guess by the time I'm going to make a window that's big enough so I think my assumptions are met. We're in real time data. Like, this is real time now, people. It's a real deal. Mm-hmm. You don't have to do that anymore. Right. You can just go as soon as possible. I mean, I have ADHD. Patience, not one of my
Not
strong
a
suits.
thing for either one of us. No, kind of have to
No.
strike while the iron's hot, because the iron cools off real fast.
Absolutely. Right? Time is money. Money is
Uh-huh.
pizza. Pizza is power. Let's go.
There you go.
And
Just give me an idea
yeah.
that ADHD is potentially good preparation for understanding the value of real-time data.
Oh, yes.
That's a different podcast. Making a note of that.
You should. This is our era, Tim.
That's that,
The
and that'll
time
have
is
to be a conversation with you. The time is now.
the time is now.
We have hopping and tumbling. Oh, sorry.
Right. And then there's session windows, and session windows are paramount. They're like the OG window. That's what I like to call them. And people can disagree or agree, but I don't care, because Kafka was invented, at LinkedIn.
Yes. Just like
LinkedIn looks at clicks and users, right? What are users basically to everybody who's doing analytics? They're a session. So I log on to LinkedIn, I have a session. People are tracking over a session. What stops a session? Well, I leave the website, right? And so what
I go
just don't like LinkedIn
away and I don't do anything. Maybe I'm still there, but I'm
the window's
not
open.
Yeah.
Inactivity. See, you just knew it. You're setting me up, right? So that's what we call it in a session window. Session windows are emitted. Their emit is driven by the window closes by a period of inactivity.
Okay.
Right? So as long as the session is active, that window keeps growing and growing and growing.
Can I define active as a message arriving with a particular key? Is that how it works?
Oh, wait for that. See? Wait.
All right. Stealing your thunder. Sorry.
Yes. So the way that session windows are they are by key, right?
Okay.
So it's not like across everybody, but by key. When I'm tracking, usually for obviously sessions and talking about people being on websites is the easiest way to explain this, right? You've got a session ID. What we want to do is we want to know what you did over that session while you were active on the website. So we set a period of inactivity that's a config, customizable. When we haven't received any information for this long from this key, we consider that session terminated. Then we go. So that's really what a session window is. It's to kind of piece together one contiguous thing, and that contiguous definition, what is contiguous, right, is how long do you have to do nothing for us to consider the next thing you do a new interaction,
a new thing. Okay.
Absolutely. So now is the fourth and final window, and I actually think you did a podcast with Leah when she put this KIP in. Those are sliding windows.
You are 100% right, and I think it would be appropriate to link to that in the show notes.
I do too. I think that would be amazing. So sliding windows, this is the nickname that I said I was going to tell Matthias, right? Sliding windows, in essence, are look-back windows.
Okay.
And the reason I say that is because when you look at these, what ends up happening is you set a thing. You say, okay, right, I want at any point in time, right, I want, let's say, 500 milliseconds or something like that, right? And so a record comes in. That record has an epoch or a timestamp on it, right? You need a 500 millisecond session. You look back and you go, okay, grab everything that was, 5,000 minus, right? And and that's your initial window, right? Then you get another window, another record that comes in at, say, 6,000, right? The window goes woo and slides. So now you're still all the time having this span that's like 5,000 or whatever I said, 5,000 milliseconds or whatever, 500. And it keeps going and it keeps going and keeps going. And there's two things that change that window, right? One is a new incoming record. The other is, and remember, like what I said, and this is also paramount to remember, when we talk about stream time advancing, right? We also look at incoming records. So what we know is, because remember, again, everything's per partition, right? So when records come in, we still advance the stream time because we know time is moving, right?
Right.
So if I'm sitting in here, that window, when a record falls out, that window will also advance, because you really do want, like you look at from the first record, right? to what it is. So it just slides along a timeline. And we should link the Java doc to this because it's really hard to understand either when I'm saying it or even if I'm in here with my little hands. It's just really a kind of difficult concept to get. And this is in one case where the Java doc is
actually
amazing.
Okay.
It's really good. Yes. So there's like and there's a table there and it shows how the window slides over time.
Okay.
But usually the situation is like if you have consistent data on a topic, right? Usually I always say like, do you know, like, remember that song? It was like, look back, but what song was that? That Don Henley song? Boys of Summer. There it is.
Boys of Summer. I
Don't
play that.
look back. You should never look back. Boom. Right? So this is the opposite of that because as a new record comes in, it goes, okay, and then looks back and grabs everything that's in whatever time window slice you need. So as they come in, it moves along. And it's really neat. So when we think about what these are used for, one of the things that is paramount is CERT. So it would be something like, like detection for incident detection, right? Because when something weird happens, you kind of want to know like what else happened around that time.
Okay. Yes.
And that is really hard to do with something like a session window, right? Because there could have been an inactivity gap right before, and then it's not in the same, right? You don't want to go based on anything.
Want a certain amount of time back. And like Don Henley in Boys of Summer, before that time, you really realize your youth is past and it's gone and you're not really going to try to get it back. Those records are not considered.
Right. And I always also like to call these like contextual windows. You basically want consistent context within a given range about what might have happened around this, right? Like, let me look and see, right? Sometimes I look a little ahead, sometimes I look a little behind, but most of the time it's a look back. So it's like, hey, I just saw this weird thing happen on, one of my proxies. What else was going on there? Is there anything else suspicious?
In the last minute.
Yeah. Well, and because we know, there's some great research going on actually in the war against Ukraine, where they have made massive strides in identifying, brute force attacks and all these kind of like cyber stuff, right?
Okay.
And what you find is the only constant is change. And it's just the same thing with credit card fraud, right? Mm-hmm. As soon as you figure out one way they're doing it, they find another. It's the same thing with this. Exactly. So it isn't that you're going to be able to identify the first event that they start with, but you might be able to identify a later one. So then you look back and you go, whoa, what else happened? And then you update your rules. It's pattern matching. It's giving you that context you need in order to like update models and do all this really cool, powerful stuff.
Could I also say that sliding windows are like hopping windows that hop continuously, or that the hopping interval is
yes, and that is actually in the KIP. That is actually in the KIP, is that the way that people tried to solve this before we had sliding windows was they'd be like tiny, tiny hop, tiny, tiny hop, tiny.
Okay, and that was resource intensive. And now I am recalling my interview
huge.
And her
yes. Right, that's not an elegant way to solve this, and we are nothing if not elegant in Kafka streams.
That is what I'm talking about. That's windowing. Now, this is frustrating because there's more to dig into. We're out of time for now. But you know what? We're not out of Anna McDonald appearances on the Real Time Analytics podcast.
What up?
My guest today.
I learned how to book I was just going to say, I learned how to book a conference room sort of today, so I can do these. Cool. Yeah.
So now we can do it more.
That's right.
My guest today has been Anna McDonald. Anna, thanks for being a part of the Real Time Analytics podcast.
It was a pleasure.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.